Hello, everyone. Good morning, good afternoon, and good evening. It's a pleasure to welcome everyone across the globe back to today's webinar event, MotusAcademy's second webinar series, Summer Edition, with the theme of Innovation in Healthcare Assistive Technologies for Rehabilitation. My name is Mark, and joining me as co-host for today's session for the webinar titled Virtual Reality, Augmenting Experiences in Functional Therapy is Daniela.
Thank you, Mark. Hi, everyone. Daniela here. A very warm welcome. I'm very pleased to be here today to host with Mark as we hear from 3 different professionals across the world to share their perspectives on virtual reality and how it has been used across the rehab spectrum to take therapy a step further.
All right, without further delay, let's welcome our speakers. Joining us for our panel today, we have Dr. Brendon Hale, Ph.D., who is the Vice President, Health and Market Outcomes Research for Penumbra Incorporated. In his role, he is responsible for ensuring that clinical and market research supports the strategic product development. He does this by partnering with academic and industry leaders to ensure the evidence generated with digital technology and therapy supports full spectrum healthcare. Previously, he led Digital Therapeutics, DTX, research team at Optum Lab, where he was responsible for developing research and product roadmaps, which supports optimizing the use of DTX technologies and devices in healthcare. His academic background is in human performance and neuroscience. He has applied this expertise to lead the development of national health and wellness programs, to design science-based behavior change approaches to use in DTX, and to develop patented personalization algorithm for the use in immersive DTX. All of his efforts are directed to ensuring that DTX technologies are adopted in healthcare and that these technologies provide value to patients, caregivers, providers, health systems, and learning organizations.
Next, we have Professor Fernando Vanderlinde dos Santos. Dr. Santos has over 12 years of experience working and researching digital games in VR for healthcare. He holds a Ph.D. in biomechanics and movement science from the University of Delaware in US, where he researched the effects of multisensory fusion on digital games for rehabilitation with the use of body sensors in virtual reality. He is also a book author and taught the use of technology in healthcare in 5 countries to more than 500 healthcare practitioners. In his current position at Bertec as a senior applied biomechanicist, he is responsible for movement science initiatives, and he also consults in virtual reality development and applications.
Last but not least, we have Associate Professor Dr. Fazah, who is a consultant rehabilitation physician and holds a medical degree from the Royal College of Surgeons in Ireland. She obtained her clinical master's degree in rehabilitation medicine from the University of Malaya. Her experience includes 14 years of service with the Ministry of Health and 12 years with the Ministry of Education. She holds an associate professor title with University Technology Mara, where she founded and built rehabilitation medicine department at the Faculty of Medicine. She's also held the Deputy Dean post for Research and Innovation. Dr. Fazah actively engaged in research and publication with over 60 Scopus indexed publications in the field of rehabilitation medicine and rehabilitation technology as well. She was recently seconded to Dehan Hospital in Putrajaya, Malaysia as the president and person in charge. And upon completion of her secondment, she's back in UITM since January 2022 and now is the Dean of Faculty of Medicine in UITM. She's currently also the Vice President of Malaysian Association of Rehabilitation Physicians.
So now that we have a good idea of who our speakers are, let us get started. We welcome questions from the audience. Please type them in the Q&A box below, and we will try our best to keep an eye on them and get our speakers to answer them live.
Okay, we know everyone now. Let's first welcome Dr. Brendon Hale from Penumbra Incorporated to share his presentation.
Thank you, Mark. It's a pleasure to be here this evening, this afternoon, and this morning, depending on where you are. Hello. I particularly like the topic here, virtual reality, how we augment experiences in functional therapy. And I think that's really what Penumbra is doing with the real system. What myself and the entire team at Penumbra we're aiming for is that we're really trying to identify how do we augment real life experiences in the virtual world, so that we enhance not only the people's ability to function, but to improve their daily lives and improve their outcome. What we do know to date is that the clinical evidence on virtual reality in healthcare is actually quite robust. As of today, we know that there's more than 5,000 published peer-reviewed journal articles. We know that there have been greater than 600 plus randomized control trials, and we know that there's been in excess of 125 meta-analyses published on virtual reality in healthcare. And so while many in the world are just coming to know virtual reality from popular science or from popular changes in some of our social media platform pursuits, if you will, what we do know is that there's been long interest in using virtual reality to enhance people's lives, to ensure that they have better health outcomes, and to ensure that we're better able to assess and monitor their health as a result of their engagement with immersive technology. So as we think about advancing healthcare through virtual reality, what you can see here is a long list. There's 20 plus evidence-based virtual reality therapies that actually have a very robust body of science behind it. And importantly, you see the list here has neurorehabilitation, orthopedic rehabilitation, musculoskeletal rehabilitation, pulmonary, cardiac, renal, vision, vestibular, cognitive behavioral therapy, and then getting into many others of distractions, therapy, exposure therapy, mindfulness-based, and et cetera. And so what we really see here is that with this capability, we have the opportunity to create what we would call a digital front door to the healthcare system. And with that digital front door, what we're able to do is really enable multimodal therapy. And so much like if you go to a brick and mortar clinic, you can come into virtual reality and access care in a number of these different rehab capabilities or rehab settings, if you will. And we can essentially satisfy both an individual's need for orthopedic rehab as well as their need for relaxation therapy, or if they had cognitive behavioral therapy needs, we could address those as well. So with a single technology, what we're really able to do is develop this digital front door that enables this ability to create care. We know that by having this functional capability that we're going to improve health outcomes for the individuals who engage with this technology. But more importantly, we know that we're going to improve their function and we're going to improve their ability to live their lives on a daily basis. As we look deeper and we think more and more about that digital front door, what we really see is that there are a number of secondary conditions that VR can support. The long list on the right was traumatic brain injury, concussion, multiple sclerosis, Parkinson's, COPD, fibromyalgia. We have this long list of conditions that VR can support. We know that it also ties to other changes throughout somebody's lifespan, like age-related changes in depressed mood or anxious mood, times in life when they might feel loneliness or isolated. The picture that I'm trying to draw here really have this very robust capability to address many of these conditions with virtual reality. So I'm very excited to have the opportunity to work for Penumbra and work in the real system, but also to essentially establish what we call a foundational knowledge in each of these as we work to build an ecosystem that enables that digital front door that I mentioned. And so how do we do that? This is one example of how we can do this with the real system, and the real system can support rehabilitation. We have a headset, we have a tablet, and we have a multiple sensor set that we include in a virtual reality kit that we're able to provide to therapists. This is able to be used in inpatient settings. It's also able to be used in outpatient settings. This allows for full body VR immersion. It allows us to create an avatar of an individual's body, and that avatar we can tie to direct movement that they engage in when they're in virtual reality experiences in the world. So we are not only able to create fun and engaging worlds, we can also create therapeutic worlds where we can measure their improvements, we can measure the longitudinal changes in their behavior, and we can do some other engaging therapeutic activities by an ever-expanding library of activities. What we're so excited about is that we're able to have adjustable settings that customize to patients. We're able to create objective tracking of their progress. We're able to create rewards-based feedback to further support their engagement and adherence. We also know that these capabilities are portable and easy to set up, and so that we can actually meet the patient where they are with the technology that they need to access therapy. All in all, what we're doing here is being able to improve functional capabilities throughout the healthcare system. What we think is so exciting about this technology is that we think that virtual reality is available across both the health and the care continuums. And what I mean by that is that we identify that health exists on a condition. We have people who are in optimal health, people who begin to suffer suboptimal health conditions. We know that people progress to have subclinical conditions, and that people might have disease and disability. What we know is that health is on this continuum, and at any point in time, an individual's health can range from all the way on the far right of my screen of disease and disability to all the way on the far left to optimal health. What we envision with this healthcare technology and virtual reality is that we are actually able to deliver healthcare on a continuum, because the same individual who has optimized health or is generally healthy, we know that there are there is content available that will lead them to continue to have optimized health, whether it be relaxation therapy or mindfulness, engagement with mindfulness worlds. We know that there's a number of things that we can do to support that individual having an optimized health status. As their health moves to somewhere suboptimal or subclinical, we also have the ability to do prevention worlds that will help them change their behavior, help them learn behaviors, help reinforce the behaviors, the positive behaviors that we're doing, as well as then when somebody progresses to disease and disability, we can deliver prescription digital therapeutics that will help them treat and or manage their disease. What we know is that we can augment therapy all along the entirety of both the health continuum and the healthcare continuum, so that we can deliver these technologies to somebody no matter where they're at on their health journey. Importantly, the objective information that we get from these technologies better enables us to support the healthcare system and help the healthcare system deliver better care, more appropriately resourced care, and ultimately more efficient care to these patients, because the objective data that we're able to generate from both the HMD, the sensors, and our ability to track and measure engagement, adherence, as well as movement, we can better monitor, we can better identify, we can better intervene, we can better treat, and we can better titrate those therapies that we need to titrate. What that results in us is using these virtual reality therapies to lead to better functional outcomes and also better functional therapy experiences for those that need to engage with it. So with that, I'd like to thank all of you. Thank you for your time today, and I welcome any questions.
Thank you, Brendon, Dr. Brendon, for sharing the realm of conditions with evidence-based VR. I really like the insight on the digital front door to use a single technology to treat conditions requiring several types of treatment. And also, it's nice to see a portable solution that can be easily applied to diverse environments. So thanks.
Thank you.
We welcome Dr. Santos from Vertec to share his presentation on virtual reality design.
I'll unmute myself. I just open my presentation. Okay, hello everyone. I hope you can hear me fine. So I'll try not bore you to that with a little bit of research that I will show here, but I put a lot of fun images so to distract you a little bit. So I'll talk a little bit about VR design, but before I talk about VR design, I want to give a little background on why I'm thinking we think about VR design and why this might be really important. And I'll show that showing a little bit of a research that one of the research that we did. So a lot of the work that I will show, it comes about human balance. Human balance is super important. You need balance for every activity and everything that you're doing throughout your day. Is not just for people that can walk. If you're in a wheelchair, you also need some balance. So it's something really important in our daily life. How do we achieve balance? So really like in a high level, we use 3 sensory systems to achieve balance. We use vision to give a direction. We use proprioception that gives you is how your brain interpret where your body is in space. So it's how you know that your foot is touching the ground right now, even though you're not looking at your foot. And your vestibular system that, again, in a really high level, it tells you where your head is in space, how much acceleration velocity you have on your head. So we are doing this all day long in every single activity that you're doing in your life. So you walk in your life and you're using those 3 sensory systems all the time. But sometimes you're using one a little bit more than the other, because you have to do something that's called a sensory reweighting. So throughout your life, throughout your daily life, you're doing sensory reweighting during the whole time and during your whole day. One example of this sensory reweighting that here in our case, we're calling as multisensory fusion is if you're walking on a hallway and someone suddenly turned the light off, you will increase the importance of your vestibular system, your proprioception to keep balance. So you're not just going to fall on the ground. So we thought this was really interesting. The lab that I work, they researched this since the 80s, and we decided to keep the research. And for that, we had our latest issue research. We decided to perturb all the sensory systems at the same time. So we perturb vestibular system with a thing called a galvanic vestibular stimulation. So we shock your vestibular system, and that gives a sense of fall. So it's mimicking fall. We would put vibrators on the ankle, so we perturb your proprioception, and we use virtual reality to perturb your vision. I'll talk about the difference, the dome and the headset in a moment later on, but keep in mind that we did this. We perturb all of them at the same time to understand their importance. This is I have material for this research to talk for 3 months, so just bear with me in this slide, and after that will be all fun, okay? So right here, we're seeing during our research, we saw the gain to vision. So we're looking just to vision. So gain to vision is how much your vision is important for how much your vision is used in each modality. So everything that's L means low vision and H means high vision. What it means is L and low and high vision. The low vision, we had a scenario that the image moved really low, really little. And the high, we have an image that moved more. So all of them with the same frequency, 0.2 hertz, but the low moved really little and the high moved more, okay? So V is our galvanic vestibular stimulation. So this is G is your galvanic vestibular stimulation, your vestibular system, and V is the vibration. So when we look at the low vision, when we take the vibration, when we have vibration on, the vision gain is high. When we take the vibration, now you have a multisensory reweighting where now you use a little bit less of your vision. So we call this intermodal because we didn't change the vision. when we go to a high movement of your scene, so a high visual movement, we see that the gain to vision is even lower. What that means is that right now, your brain can understand that that visual movement is not that real anymore, and now will not relate to that movement as much anymore. And we'll try to use, even though you're perturbing all of them, you will try to use the other systems more than the vision. So with that, what we see is that all those perturbations that we do using really high velocity in vision are not really doing much as when you do a really low vision movement for perturbations. With that in mind, and we call intermodal, I'm not going to go really far on this research, right? But that got me going deeper and deeper in vision and trying to understand why vision is so important to it, and why so many people do research with hand-mounted displays sometimes and with virtual reality and says, oh, with hand-mounted display, people sway more. With hand-mounted display, people were worse than walking. Most of that has to do on how you create a virtual environment. So I could be talking here about uncanny valley. That is when you try to do too realistic and you end up missing the mark, and it end up being not as good as you're doing like square images, right? So that's in uncanny valley. We can talk about when you cannot see your hands, when you cannot see your foot in a virtual reality. This also makes difference. But I want to bring a little bit more to the patients a little bit, right? So, and I use this phrase a lot in all the courses and all the talks that I give about this is like, what looks fun and cool is not always good for your patients. So a lot of people look at virtual reality and they go like, oh yeah, I'm going to play this game because the clinician is using with me. That game, I'm going to buy a headset myself, I'm going to do at home. And then suddenly they go home and they get dizzy, because that game was not made for the rehabilitation, was not made for them, it was made for people that are healthy, by people that are healthy, right? And we still have this problem, even like a lot of development for healthcare sometimes are done by healthy people, tested by healthy people, and we need to understand why our patients actually need it, right? So we have to think about people that have visual sensitivity, people with concussion, people with Parkinson's, vestibular deficits. It's a big deal, right? So if I talk about visual sensitivity in concussion, because concussion has visual sensitivity, you have to think about even colors make difference, right? Using the color blue and the color yellow, those will make difference in a patient with concussion. We know the blue light has an effect to people with concussion, that the yellow light will have an opposite effect. So we also have to understand that. I know the more you start looking at this, you see how complex it is. It's so easy to create a virtual reality scene and create everything. It's not hard to go in Unity 3D and go create something, but create something that is meaningful is really important, right? And what your patients will want to do. So I have some examples, and I'm not going to go in depth on the vision here because I don't have 3 hours. So, and when we're talking visual perception, I always like to bring Gestalt, right? And so Gestalt principles that talk about proximity, similarity, color code. Those are things that people that study UX, they know a lot about that because they use that for their work. So I'll tell you about proximity and similarity. So proximity, I'll give you an example. If you do a scenario that a person is walking in a forest and you have a lot of trees, one really close to each other, your brain perceives that as one object because they're too close to each other and they're similar to each other. So if all the trees are the same color and they're too close, you perceive them as one object. The more you separate them, the more you will perceive them as separate objects. If you interpolate between those trees, doing like 2 green trees, 1 yellow tree, and another 2 green trees. Now you perceive those 2 green blocks as objects and the yellow as a space between them. Why this is important? Because there's other thing I also call motion parallax. So motion parallax helps you with depth perception. And if you cannot understand your depth correctly, you cannot perceive velocity correctly, and now you're overshooting or undershooting everything that you're doing in virtual reality. So you also need to understand those kind of things when you're doing development of those scenes, right? So just an example of motion parallax. I don't know if everyone knows. I have a GIF there as an example, but it's too much. But motion parallax is something that you can do it right now. You can see it. So if you put your thumb in front of you and you move your hand, you can see different parts of your finger. So you have this 3D perception of your finger, and that happens with your environment. When you don't have motion parallax, you perceive as like you're looking at TV, or simply is your wallpaper moving around. So it's not really immersive to it. I already talked about parallax here, and parallax and velocity, they're really related, as I said it before, right? So you guys just stop me if I'm going too fast, but I'm trying to go with everything. So I brought some examples of some research here, and I just want to bring it over really quick. I don't know if you can see my pointer here or not, but if you look to the video on your left, you see it's our spaceship tunnel. And if you look at the center of that spaceship, you will see that the tunnel is moving a little bit. That tunnel is moving a little bit because I have a sensor on my head, and the tunnel is moving in relation to my head. So for whom is outside, it looks like the tunnel is moving a lot. But for me that I'm walking there, it looks like it's perfect center working as it should. And that's a way to do motion parallax. So that's why a lot of times you look at what someone is looking inside a headset and it looks really weird, right? You will look weird for whom is outside of virtual reality. So this is one example. Other example of what we will do. This is a fun experiment, right? But again, the sensor on our head and control the spaceship. This one here on the side is controlling the airplane with the hand. Well, we had a lot of studies. We have done a lot of research in it, and I have just to show a little bit about what we do in clinical too. So a couple of examples of that, we have our posturography. So this is a dynamic, computerized dynamic posturography. So the floor moves and the scenario here moves. This has 220 degrees. So the person is inside there. So you have actually full peripheral vision on that. Right now, it's used for concussion. We have American Academy of Neurology, several doctors there pointing as the golden standard for balance assessment. And we have sensor organization tests, optokinetics, cognitive tasks, balance training. So what you're seeing there is a new scene that I developed last year. So that's why I talk about trees, because that's how one of the ways we develop that scene. And right here on the side is not really virtual reality, because there's a whole discussion about virtual reality, right? But this is a touch screen where you can put any background that you want and do your exercises. And to finish really quick, pros and cons of virtual reality. There's so many pros, right? Virtual reality is fun, is engaging. You can collect data. That's, to me, one of the biggest draw to it is you have data. You can collect data and you can make your assessments with numbers and not with feelings. So that to me is why I started working with virtual reality long 12 years ago, because I could see that it's so beneficial for clinicians to show progression, right? The cons are depend of the virtual reality set, but virtual reality not well designed can be worse for a patient than good. Virtual reality has a learning curve, not only for the patient, but for the clinician too. I put as a con, but it's not really a big con because any new treatment also has a learning curve. So any new treatment, you need to learn as a clinician how to do it, right? I put as a con, but to take with a grain of salt. If you go to a headset, head-mounted displays, so the HMDs are great, but it also depends on the patient, right? So there's patients that will not tolerate that because of their level of dizziness and their level of motion sickness. It can be treated. And maybe you can use the head-mounted display to treat them too. But you have to work on that scene design, right? So although there are some cons, I always like the pros way better, right? And again, data. You having data, you can show your patient, this is amazing. I know we talk about engagement and everything, but we talk about engagement since 2009, 2008, when we were using Wii, right? So things are coming and people are starting to understand virtual reality. And I still have people that ask me if virtual reality should be in clinic and we should bring this and we should use virtual reality. I'll say what I tell to everyone is it's inevitable. People have virtual reality in their house. People have virtual reality everywhere. Why not use in clinic? It's inevitable. If you don't start using, your competitor will. So if you think about market, if you think about your patient, if you think about the way the future is going, I see way more pros than cons. And thank you so much, everyone. I have to thank Bertac. It's the place where I work, University of Delaware, where I did my PhD, Cobalt Lab. That's the lab where I did a big part of my research. I'm the one hanging, not by the neck. I was holding on the harness. And that's all. Thank you so much.
Thank you, Dr. Santos. It's been very informative to hear how best to manipulate VR to benefit the patient. Definitely more than meet the eye, especially when you start talking about all this parallax and all that. Very, very interesting. There's definitely more depth to what the common population sees in VR, and it has definitely moved a long way. So thank you very much. And finally, let us welcome Associate Professor Dr. Fazah from UITM to share her presentation on medical rehabilitation using VR. Over to you, Dr. Fazah.
Thank you very much, Mark. Is my screen showing okay? Lovely, thanks. Okay. So what I'd like to share this morning is medical rehabilitation virtual reality in a clinical sense that we've had experiences in the Faculty of Medicine, UITM in Malaysia. So a lot of the things that I'm going to explain and share with you is very much what Brendon and Fernando had also shared in their talks. And at the end of this session, I will have some videos to share with you with regards to what Brendon and Fernando had also expressed in their talks and how it relates to a clinical setting. So before I begin, I'd like to acknowledge and also do a disclaimer that this project was supported by Bestari Grant. It's an internal grant, research grant from UITM. And it's also a collaboration with Moshe Fixo Sendirian Berhad, which is a company. And I'm also a co-founder of MRVR, Medical Rehabilitation Virtual Reality. So the talk will be primarily looking at three-dimensional virtual reality in rehabilitation. And just like what Fernando had explained, you know, VR has been around for many years, and we've been using VR since since 2010. This is one of our first devices that we procured in the faculty using Xbox 360. And this is one of our traumatic brain injured pediatric patient. And he enjoyed using virtual reality, and there were games that the patients could apply on. But just like as what Fernando said, it's not specific for patients who require rehabilitation, and the patients that we see at the faculty at the university in our clinical setting are patients with complex disability. So complex rehabilitation using off-the-shelf commercial games are usually not appropriate, though we can use some of the aspects, like this child is playing with the bowling virtual reality set, which helped him with the balancing of his rehabilitation program. So with that in mind, we decided to sit down as a team. We had a multidisciplinary team that looked into this, the medical, the computer scientists, and also the physical therapists from our Faculty of Health Sciences. And to come up with games, just as what Fernando had expressed, or the modules, we used existing theories or approaches that we have in our daily rehabilitation practices. So the first theory is looking at an enriched environment. And again, this is a schematic and dramatic picture showing a simple study looking at rats, and an animal study. A rat that was put into an impoverished environment as compared to those that were put into an enriched environment. They saw that the rat brain cells developed more in an enriched environment. And we know that. So for some of us who are clinical teachers here, when we teach our students in an enriched environment, they also learn a lot better. So that's one of the first theory that we use when we come up with virtual reality modules. Goal-oriented cognitive rehabilitation for our games or modules were also put into this. And again, this is not anything new. This is a study that was done back in 2010, where they used goal-oriented cognitive rehabilitation for people with early stage Alzheimer's disease. And in this study, it also showed some positive effects of using goal-oriented activities. And this is another study that was published in 2019, which showed goal-oriented activities showed better recovery in older adults, regardless of their pathology, whether it be stroke, Alzheimer's, or even physical disabilities as a result from broken hips. The third would be mental imagery. So again, this is nothing new, but that we use on a daily basis in our rehabilitation program. This is the use of a mirror box where the paretic or the impaired side is seen in a reflection, showing the good side. So in a way, it not only tricks the brain, but it helps with the neuronal connectivity in the stage of recovery. And fourth would be gamification. So gamification of cognitive rehabilitation has shown some positive influence in recovery of patients with complex disabilities. Okay, so virtual reality in the combination of an enriched environment, mental imagery, goal-oriented tasks, and element of gamification, which is engaging and fun, has been put into the way that we create the modules with 3D virtual reality. So what are the existing evidence? I think Brendon had shown a lot of evidence that is available in the scholarly research that has been published. But this is just an example. This is a meta-analysis and systematic literature review of virtual reality in rehabilitation program that was published in 2017 by Matt Howard. And he in the studies that he looked at, most of the outcomes were based on motor control, balance, gait, and strength. And through this systematic review, he found that the virtual reality rehabilitation programs are more effective than just traditional rehabilitation programs for physical outcome. And the factors that were proposed to cause these improvements were very much related to the way that the rehabilitation programs were conducted. It's more exciting. And it had a lot of element of physical and cognitive fidelity. And you can just imagine things that we require to build physically can be quite challenging financially and space occupying. But when you put it into a virtual reality, the fidelity in terms of physical and cognitive could be anything that we could imagine that we want to incorporate in our rehabilitation program. However, future research and practices are still required because even though the numbers of the studies are large, but the participants are usually quite small. Another lit review that was done by Marjo that was published in 2018, looking at cognitive rehabilitation patients with traumatic brain injury. And this is a narrative review. And in this study, they found that not only is it effective as a form of a rehabilitation tool, but also effective in the form of assessment for the treatment of cognitive and behavioral impairment of patients with traumatic brain injury. So with these background theories and evidences, our team got together and we started doing the discussion, planning, and the execution of the MRVR. So I'll just show you a few examples of what we've done. This is one looking at multisensory room. We had a lot of issues in building our multisensory room because it's so expensive. So we decided to put it into a virtual reality module. So you can see here that there are different activities within the multisensory room, which enhances a lot of sound. The handsets that they held had vibration or biofeedback, and that gave a lot of different sensory. Second was back to kampung. So we had an element of something of familiarity with the population around the Southeast Asia. This is kampung, means village. So there were a few activities that the patients could relate to, you know, going and taking eggs and activities within the kampung. The third here is going deep into sea. And here again, we got a lot of relaxation therapy and also some hand dexterity and cognitive activities within this module as well. Okay. We do have a set of activities that goes along with the observation and the modules that we put in here. The fourth module that we did was one of our PhD students' project. And this is dual cognitive therapy that we put into 3 challenging environments. So the first environment at the top there is a serene village area, very quiet. Second is a more challenging, they're walking down the street having to deal with obstacles, you know, people walking with them, against them. And the third would be a very noisy environment. So these are things that you would expect somebody to be able to do on a daily basis when they reintegrate back into the community. To be able to function in a multi-challenging environment for both sensory, you know, vision, hearing, and also physical obstacles. Yeah. So that multitasking is very much important for functional reintegration. So this is an example of a patient. She had stroke. She recovered physically quite well, but again, she could not go back into the community because she would lose balance when walking with a lot of multiple senses that she had to deal with. So with the virtual reality, we moved her along the different challenges of the 3 scenarios that we set. And at the same time, we asked her to count backwards. We also had sensors looking at her gait while she was doing this, and we saw a lot of deviation in the initial instances, and with training, these deviation improved. So I'd like to share with you one of our case studies. This is a 57-year-old gentleman who had a stroke in January of 2019 with right ischemic infarct that resulted in left body hemiparesis. So you can see in the first picture here, he was on tube feeding. He required 2 persons to transfer him from the chair to his wheelchair. And he was very much dependent on his caregivers. It's not uncommon that patients that were admitted to our acute hospitals, they don't stay very long in the acute hospitals. Not all hospitals have rehabilitation facilities. So he was discharged 2 weeks post his, he was discharged 2 days post his stroke home. So when the rehab facility within our medical center had an opening, he was admitted 2 weeks after the stroke. So he underwent the usual conventional rehabilitation of gait training, balance, constraining movement therapy, trying to improve the left hemiparetic side. And we enrolled him into our rehabilitation program approximately 4 weeks after he had the stroke, and that was in March. So you can see here, you know, at first we were quite apprehensive whether he would be able to take on the headpiece, the HTC Vive headgear. And we had a session where we taught him how to use the device first and to see whether he can tolerate. And quite amazingly, he could. And he got very excited. So the first part of the teaching was on chair sitting. On the same setting, sorry about the visual challenge there, he was able to stand using a cane within the same setting. And he was able to tolerate using the virtual reality headset for approximately 45 minutes. Okay, so this is him in our multisensory room. We did this once a week. He came in the next week and we challenged him with standing. So this is him using the virtual reality program within the same sensory room, but now he can stand without using his cane. In fact, he told us that he had more confidence knowing that he was in this protected environment, but yet given the challenges that he would see out in the real world. And he didn't even realize that he was not using his cane at this point in time because he just felt so secure with the program. Okay, and just to remind you, this is how he was in March after a month of completing weekly MRVR therapy with us. And he was able to walk without using his cane. He was actually carrying his cane there. And this is him in May of 2019 in the next video here, sorry. And you can see there is still a little bit of a gait disturbance, but you can see that he is now more confident in walking. As you know, he's a retired police, auxiliary police officer, so he does the marching that he does on a daily basis before he retired, and he enjoys being able to go back to that activity. Okay, and this is approximately 6 months after his stroke. And you can see the fluidity of the movement and the ability to balance himself in a squatting position. Personally, I don't think even I can do that. And this recovery is expedited with the augmentation of virtual reality. Don't get me wrong, virtual reality does not replace physical therapy and cognitive therapy that we do conventionally. So this is something that we put on top or augment his rehabilitation program. So just to tell you that this is not a one-hit wonder, we also have other patients that uses the MRVR, and you can see that the engagement of patients using MRVR is very much motivating even for the clinicians. When we see that the patients engage in their activities, it also helps motivate the clinicians to continue with the therapy. Yeah. So this is egg collection, and you can see that there is a lot of hand-eye coordination and also balancing. This next video here is she is trying to carry the tray with the cup, and again a lot of balancing there. Yeah, and she's able to do it. Yeah. In physical therapy, she always had the fear of the cup falling, so that put her back in the engagement of the therapy. Yeah? But when you immerse them into a virtual reality environment, the element of fear is actually taken away, so that allows them to be more engaged as well. Okay, so we've got improved features. You saw that the videos that we had earlier, they had the tethered device. So now we are using Oculus Quest, which is untethered. And also we have put in some improved features. Improved features where we can look at the movement quality, and again, as what Fernando said, collecting data as well. Yeah, so that, and also another monitoring features that we use here as well. Okay. So in conclusion, theories and evidence are used to create the MRVR scenarios. We use serious games targeted towards clinical outcome measures. It's fantastic that we can use high fidelity for both physical and cognitive fidelity to create the games or the scenarios. It's an affordable alternative to physical environment, definitely for those who don't have the space or the money to create this physical environment. For example, our multisensory rooms. Virtual reality is a great alternative. Promotes rehabilitation through engagement and participation. It's also mobile. Our first patient, we actually brought the device to their homes. Potential of adding AI to measure outcome, remote monitoring, and analysis and reporting. And the pilot studies that we've done is suggestive of positive clinical outcome. So next, we want to expand the modules to cover a wide range of rehabilitation therapy. And I think this is where we can actually work with Fernando as well. And creating hands-free modules and bringing in more evidence, because if you don't have evidence-based medicine, it's going to be difficult for us to change the perception of the medical fraternity to uptake and adopt virtual reality. Accessibility, we're at a pre-commercialization stage now. And the sustainability, as what I've mentioned, becomes a standard rehabilitation practice. And I like the fact that Fernando had mentioned that if you don't use it now, your competitor will. I'd also like to thank our MRVR team at UITM. So we have a multidisciplinary team here of physiotherapists, of computer scientists, and I cannot thank enough our PhD students and our research assistants. And in collaboration with also our industry partner, Motion Fixers and the Rainbow Hat. Thank you very much.
Thank you, Dr.
Thank you.
Fazah.
All right.
Yeah, thanks for like going through the process that you guys came up to develop the MRVR scenarios, like all the key components that is behind the fun game to play in the applications with the patients. It's very nice. So next we will move on to the questions. So there's several questions on the Q&A. Some that have been answered and others not. So let me see one here. Okay, I will read over like one for with the inclusion of parallax and velocity aspect in VR. How accurate is the tech in simulating a real life environment? For example, in the case of GAIT therapy for a stroke patient, would it affect patients' GAIT when changing from VR GAIT training to real life GAIT training? So I think Fernando answered, but if you can just answer live.
Yeah. So really good question. So let me just remember what I answered, because I was trying to read the other ones too. So yeah, so first of all, yes. So if you take in consideration parallax, velocity, and everything, it is good. I will say I like to take consideration those visual factors to people that have visual and vestibular problems. When you're doing something more orthopedic or neurologic, not visual, vestibular, might not be that bad for the person. It's always better if it's well designed, right? But it will be bad for people that have vestibular problems. But going back to the answer really quick, yes, can be great, right? It can be great for helping balance walking or standing. We just have to keep in mind that we don't want the scenes to be realistic as pointed too realistic. We go back to what I said before of uncanny valley, makes people uncomfortable and create fear in a way that is not really good to people. So what we use right now a lot, and I've been talking a lot of people, we use objects that are low poly. They're less triangles on the images. So where you can understand that that's a tree, but it's not a tree that is so realistic that can generate any fear. Trees, cars, those kind of things, they will not create that much of fear, but avatars and other people freaks people out. It's something that is real and is really interesting. But I will pay more attention to not to realism, but the movements that you're trying to create to the people and to the image and the feedback. Right, the feedback that you have from the image and the movement.
Yeah, that's a very interesting point. I have a follow-up question on that, because how do you deal with the emotions? Because I see this is not only related to VR, but to gamification. But sometimes you have like games that people shoot a bunny, and then some people like to shoot a bunny, others don't. And, and that kind of like gets into the way of the treatment. So how do you deal with that when you develop the scenarios?
We have zero shooting. We don't build anything with shooting anything, just in case. I had a water gun shooting, But even there are some people that cannot have any type of gun, any type of shooting. So we just decided, you know what, we don't need that. We can have someone throwing rings or someone throwing a ball or something like that more than a shooting, or pointing to some place and trying to touch. And that has to do with the emotion. A quick sidebar here. When I started creating scenes, when I had my own company, 2009, I had we had a behavior psychologist that worked with us in game design that used to tell us what is the message that has to have, right? So when you play Wii and they say you lose, imagine you were a patient, you cannot walk, you cannot do anything. You go to the therapy feeling like really bad, and you go to your therapy, and your therapy tells you that you're a loser and you cannot do it, right? That should be a safe space to you. So the image should not be that. It should be like, nice try again. So I ended up learning a lot with the behavioral psychologists on that, as colors, as type of music. We don't look at 100% of everything, but it's really interesting how the psychological makes so much difference.
Right.
And I just want to say that I heard one thing from her that she said that that I took a note, because VR does not substitute physical therapy. That's something that's so big, and I repeat this so much. VR does not, is helper, is a tool for it. And people had to stop to do, some people get a headset and say, what can I do with headset to help people? And that's not the direction. The direction is, I have this problem, what can solve? If the headset can solve, I'm going to use a headset. It cannot be the opposite. I cannot have a head-mounted display of VR and try to discover, oh, I'll try to do, that's not the path that we do. Because we don't do anything like this in therapy, right? You're not walking the street and say like, oh, I'm doing this movement. What pathology I can do with that? No, you look the pathology first, and then you see what you can do. And head-mounted display is the same thing.
All right, thanks, Dr. Santos. That's a very important point, I believe, for a lot of us to take away, especially people who have questions about VR and are using or believing in it. Great advice. Now, I do have a question here from an anonymous attendee asking Dr. Fazah. So it reads as a great insight for clinical setting, Dr. Fazah. But what do you think of that is the priority for stroke patients when it comes to selecting VR technology tool for their therapy?
Okay, thanks, Mark. Great question. If we look at the rehabilitation program in the years, you look back approximately 50 years ago and what it is now, the generation of new knowledge is there, but it has not changed practice at a rate that we would like it to. So if we look at technology, there is still a lot of hesitancies and the change of applying new methods to the rehabilitation because of that lack of clinical evidence that we want to see. So I think for those who are in the frontiers or wanting to see this come into real practice, we have to make sure that we work together in finding and coming up with clinical evidence, because there's no point in having something that we want to reinforce into the fraternity, into the clinical, changing the clinical practice if we don't have the evidence there. From our practices, yes, we see it. And to say that it is a priority, I would say yes, because this is something that will augmentate the recovery of our patients. If we had a choice of doing something conventional and the outcome is the same every time with different patients, and now we have new technology that can enhance the outcome, I do not understand why we cannot consider this as a priority. And as the technology evolves, it gets more refined. We're getting more clinical evidence from it. It's also getting cheaper. If we look at coming up with a virtual reality, the gears that you need, it doesn't cost that much as compared to what you would need to physically build an environment for them. Yeah. So again, it helps with the administration of the hospital or the caregivers or the industries that are giving this care, not only in terms of the outcome, but also in terms of the return investment of monetary and recovery, not only for the patients, but also for the extended network that the patient is living in. Their families, if they're still working, getting them back to work at an earlier stage after the stroke or any neurological injury. This will all have a cascade of positive effects. And I think this is where the priority has to be made realized for all those involved in rehabilitation.
Thanks, Professor Fazah. So I would like to thank you all for joining us today. We hope you have enjoyed and learned from the experts on today's panel. And we'd like to bring your attention to this poster presentation that's being shown. On the left is the poster for the next webinar, which will be on the 9th of June with the topic Neuromodulation, Research and Application of Transcranial Magnetic Stimulation. The link for the registration is provided in the chat box. While on the right, we have the QR code that leads you to the feedback, from where you will also find a section to fill out your name and for the certificate that will be issued for your participation. We appreciate your time and effort to fill in this. And for now, bye. Next week. Bye, everyone.
Bye, thank you.
Thanks,
Bye, thank you all.
everyone.
Thank you.